In this lesson, we are going to be talking about additive relationships. This concept is building off of the previous concept, proportional relationships. In the last section, we talked about the proportional equation y equals mx, where m was the slope of the line. Now we're going to be looking at an equation that is very similar. Y equals 1x plus b. Now, this is called an additive relationship because the slope of the line is always going to be 1. No matter what the situation, we're never going to look for a rise and a run because it's always going to be 1. The new piece is this piece called the b. This is called the y-intercept. This is where the graph of the line crosses the y-axis. Something to remember is that this does not pass through the origin, unlike the proportional relationship did. Let's go ahead and look at this first example. Now, the first thing I do want you to look at is the slope of this line. I know I said we weren't going to talk about the slope, but I just want you to see it. I'm just going to go ahead and pick 2 points. I'm just going to go ahead and pick this point and this point. And if I did my rise over run, I would rise 1 and run 1, and my slope would be 1. So the slope of all of these lines is going to be 1. Now I'm going to go ahead and erase that because I really want to focus on the y-intercept, which is the b. The y-intercept is where the line crosses the y-axis. In this first case, you can see that this is where it's going to cross the y-axis. Just as a refresher, this is my x-axis and this is my y-axis. So you can see that it's crossing the y-axis at positive 2. That is called my b. Now to create the equation, I'm going to write y equals, now you could put 1x or you can simply just put x. And I'm going to say plus 2. Y equals x plus 2 is the equation of this line. Let's try another one. Now, I know that this slope of this line is 1. So I need to now figure out what my y-intercept is. So my y-intercept is right here where it crosses the y-axis. You can see -1, 2, 3, -4. Looks like it crosses at -4. That's my b. So my equation would be y equals x minus 4. Let's try the next one. Well, the slope of this line is 1, and I have a y-intercept right here, which is at -1. That's my b. So my equation would be y equals x minus 1. And then the last example, my slope, of course, is 1, and my y-intercept is, it looks like 5. So my equation would be y equals x plus 5. These are all additive relationships. All right, now let's go ahead and take a look at the table of values. This is a little bit different than a proportional relationship. So we're still going to be using that equation, y equals 1x plus b, or x plus b. And I'm going to look at this first table. Now, to determine the b, or the y-intercept, I want to find where x equals 0. This right here is my y-intercept, meaning my b is 3. Now, sometimes you're not given a table of values that actually shows you the y-intercept, or in our case, 0, 3. In that case, this is another way that you could determine what the y-intercept is. If you look at the first 2 coordinates, I'm going to go ahead and put a box around them, -1 and 2. You would ask yourself the question, if I started at the number -1, how many units would it take me to get to positive 2? So -1 to 2, that's 3 units. So you added 3 to your x to get to your y. That is how you get your y-intercept. Another one we could look at is here, 1 to 4. This might be a little easier to look at. But how did we get from 1 to 4? Well, of course, we added 3. That's why they call it an additive relationship. I could also say 2 to 5, well, I added 3. So that's my y-intercept. So y equals x plus 3. Because what you essentially did is you took your x value and you added 3 to it each time. All right, let's look at another one here. You might be able to identify your y-intercept right off the bat here. My y-intercept is 0, -4. So that means that my b is -4. Now, just to kind of double check myself, let's go ahead and see what the additive portion of this relationship is. To get from -1 to -5, I added -4, or in another way you could say it, you subtracted 4. But we're talking about additive relationships, so that's why I wanted to say add -4. Now, I could also say 1 to -3, well, I added -4. And then 2 to -2, I added -4 again. My equation is going to be y equals x minus 4. And you might be thinking this question, why didn't I write it y equals x plus -4 like that? Well, anytime these two operations are next to each other like this, the negative always takes over. So it would be x minus 4. So it's really just another simplifying step. Okay, the next one. Now you can see that I have my y-intercept as 0, 5. So my b is going to be 5. At this point, I could go ahead and write my equation, but I just want to see the additive relation here. So -2. I want to get to 3, so I had to add 5. -1, to get to 4, I had to add 5. And then 1 to 6, I also had to add 5. So y equals x plus 5. And then the very last one, my b or my y-intercept is going to be -1. And -2 to -3, I'm adding -1. And then -1 to -2, I'm adding -1. And then 1 to 0, I'm adding -1, giving me y equals x minus 1 as my additive equation. All right. Now, what we're going to do now is we're going to take our understanding of proportional relationships and additive relationships and put them all together. This is an equation, this is an algebraic equation called slope-intercept form. This is a very popular topic in Algebra 1. The equation is y equals mx plus b. Essentially, it's the exact same equation as the additive equation, with a little bit more flair. Now, the m, we know, is our slope. This is our rise over run. And our b represents our y-intercept, where the graph crosses the y-axis. Now, let's look at this first equation. And what I want to do is I want to determine the slope of the line and where the graph crosses the y-axis, and then determine the equation. First, let's find the slope. Go ahead and select 2 points. I'm going to go ahead and pick this point right here and this point right here. It doesn't matter what 2 points I select. Now, I'm going to go from left to right. So I'm going to rise 3, and I'm going to run 1. So you can see that my rise over my run, I'll write it right over here, my rise over my run is 3 over 1, which simplifies to 3. The slope of this line is 3. So I'm going to write m equals 3. Now, my y-intercept is where the graph crosses the y-axis. So you can see that that is right here. The y-intercept is at 1. So to put this equation together, I'm going to put y equals my slope times x plus my y-intercept, which is 1. So the equation of this line in slope-intercept form is y equals 3x plus 1. All right, let's try another one. I'm going to go ahead and select 2 points. I'm just going to go ahead and select this one right here and this one right here. Let's go ahead and find the slope. So I'm going to rise 1 and I'm going to run 2. So you can go ahead and I'll put that right over here. Rise over run is 1 over 2, which that does not simplify. So my slope of this line is 1/2. My y-intercept is right here where it crosses the y-axis, and that's at -2. So to piece it together, y equals 1/2 times x minus 2. Okay, this next one. Now, I only have 2 points here, so let's go ahead and look at these 2 points. So I've got this point and this point. My slope, let's look, is 2/3. So rise over run is 2/3. So that's my slope, 2/3. My y-intercept, well, you can see that my y-intercept is one of those coordinates here. So it looks like it's at -4. So my equation will be y equals 2/3 x minus 4. All right, feel free to pause the video and give this one a try before I answer it. All right, I've got 2 points. I'm going to go ahead and select this point here and this point here. My rise is 2 and my run is 1. And 2 divided by 1 is 2. So my slope is 2. My y-intercept is up here, +3. So my equation is y equals 2 times x plus 3. All right, and that's slope-intercept form. Now, I want to go ahead and kind of put it all together now. I give you an equation in slope-intercept form, and what I want you to do is graph it. So looking at this first one, y equals 2/3 x plus 1. The slope of this line, you can see, is the number that stands right before the x. So the slope of this line is going to be 2/3. And the y-intercept is going to be +1. Now, to graph this, I always want to start with my y-intercept. I'm going to go ahead and put a point where the y-intercept is. So I'm going to go ahead and put a nice point on +1 on my y-axis. Now, from that point, I'm going to go ahead and rise up 2 and run 3, leading me to this point here. Now, you could go ahead and draw a line at this point, or you can go ahead and try to continue this pattern. The pattern continues, it'll also have a point right here. When you've drawn all the points that you can on the coordinate plane given, go ahead and draw a nice straight line through all of those coordinates with little arrows at the end, saying that this line will go on and on forever and will have that same slope. All right, one more. So the slope of this line is 3, and the y-intercept is -4. So I'm going to start by graphing my y-intercept, which is right here. So -4 on my y-axis. And now this is a little tricky here. My slope is 3, but remember, slope is broken into a rise and a run. So if I wrote rise and run, and I figured out, well, 3 is actually 3/1, my rise is going to be 3, and my run is going to be 1. So let's go ahead and graph that. Now I can continue that pattern all the way off of my coordinate plane, or at least as far as it will go. All right, now let's go ahead and draw a line through those coordinates and arrows at the end. So this is a line, y equals 3x minus 4, and this is given by the equation that's in slope-intercept form. All right, that brings us to the end of our lesson on additive relationships.